So thank you for coming out and braving the weather. And I'm really looking forward to spending some time tonight talking about what I think to be maybe one of the most important questions anybody could actually ask and then seek an answer to, and that is, does God exist? And because I would contend that that question, does God exist, and the answer to that question, yes or no, and then if you answer yes, how do you understand the nature of God, is essentially what is foundational to everybody's worldview, everybody's philosophical framework in terms of how they view life, how they view reality. And so this is really an important topic that I think is well worth our time discussing this evening, and I'm looking forward to having a lot of fun with you tonight talking about this really important question. Now, what I'm going to do tonight is address this question by telling you why I believe God exists. And I'm going to take a look at this question from the standpoint of someone who is a biochemist and then also someone who is a Christian. And before I get into my argument tonight for why I think God exists, looking at some evidence from biochemistry and origin of life research, what I'd like to do is tell you a little bit about my story, a little bit about my background, so you can kind of understand where I'm coming from and how I'm thinking about this question. Because we're going to be talking about this question tonight, again, from a scientific standpoint. We're going to talk about scientific reasons for God's existence. And I didn't grow up in a Christian home. My father was a Muslim, in fact. And he was also a nuclear physicist, a college professor. My mom was a high school science and math teacher. And so we grew up in a home where basically our view of Christianity in our household was rather negative. And on top of that, we grew up in a home, my brother and I, where science permeated everything about our lives. And in fact, education for my parents was the most important thing, the highest priority. So that was the environment that I grew up in. By the time I graduated from high school, I was an agnostic. I didn't know if God existed or not, and I honestly didn't really care. What was interesting to me was, believe it or not, biochemistry. And I went to college, and I wanted to do everything I could to prepare myself to go to graduate school to get a PhD in biochemistry. That was the sum total of my focus when I was in college. And so I took courses in chemistry and courses in biology and wholeheartedly embraced an evolutionary view. The idea that the origin of life and the design of life, the history of life, could all be explained through evolutionary mechanisms. And again, I accepted those ideas without any reservation. And it was when I was in graduate school where I began to study biochemistry in depth, where I began to read the scientific literature, learning about the latest discoveries that were being made. As I began to do my own research, really immersed in biochemistry, I began to fully appreciate the elegance and the sophistication of these chemical systems inside the cell. And was just astounded by just how ingenious these systems were. And ingenuity and ingenious is the word that almost always would come to mind when I would think about how these systems were structured, how they would operate. And so I asked myself, how do scientists explain where these systems come from? And of course, as an undergraduate student, the explanation was, well, it was through the origin of life process where chemicals self-organized into the very first cells. But I was a graduate student, so I wanted to know the details. I didn't want just a superficial explanation, I wanted the details. And so on top of all the work that I was doing as a graduate student that was required, I spent additional time studying the origin of life problem just so I could answer that question. And after about 6 months of investigation, I can remember it was the summer the summer between my first and second year of graduate school, I came to the conviction that there's no way that chemical mechanisms could generate the types of systems you see inside the cell, that there had to be a mind behind it. And so it was the ingenuity of these systems coupled with the inability of, I thought, evolutionary mechanisms to explain the origin of life and hence the origin of biochemistry that convinced me that there had to be a creator. And it was then several months later that I was presented with the gospel and I responded to the gospel. But I've spent the last 3 decades or so actually continuing to revisit this question. Can we explain the origin of life through chemical evolution? Is the evidence that I saw for design as a graduate student stronger or weaker in the ensuing decades from when I reached that initial conviction? In other words, I've been applying the scientific method to this conclusion that I've drawn, again, for over 3 decades. And in fact, several of the books that I've written essentially reflect that ongoing interaction with that question. Origins of life, the cell's design, creating life in the lab. And so I've continued to explore this question. So what I want to do tonight is explain to you 30 years later why I still believe that God exists as a biochemist and as someone who's a Christian. Now, before we get into this topic, though, one of the things that I want to address this evening is this question. Can science detect the work of an intelligent agent? Because what we're doing, the argument I'm going to be presenting tonight is essentially a scientific argument. I'm going to argue from scientific evidence that a creator must exist, that an intelligent agent must be responsible for the origin and the basic design of life. And if that's the case, then we need to be able to show that science has the capacity to detect the work of an intelligent agent. Because so often when I'm engaging people that are skeptics or that are seekers who are yet still not convinced about the idea of God's existence, when you bring up the idea that there's scientific evidence for a creator, their first reaction is to say, well, that's actually outside the bounds of science. That really is a question of philosophy or theology. It's not a scientific question. And what I'm going to argue tonight is that those boundaries between science and theology and philosophy are probably far less certain than many people would like to believe. And so I'm going to press against those boundaries by arguing that science actually has the toolkit to detect whether or not intelligent agency is responsible for the origin of life. Now, to do that, I'm going to, first of all, point out to you that there are actually a number of scientific disciplines that actually are intelligent design disciplines, where that discipline is designed in such a way to look for the work of intelligent agency. For example, forensic science is one instance. And of course, this is the science of crime scene investigation, right? People apply the scientific method when they go into a room and they find a dead body. Was that body, or did that dead body, or that person die, I should say, due to natural processes, natural causes, or was it the work of a malevolent, intelligent designer? And in fact, not only can you tell whether or not an intelligent agent was involved in the death of that individual, you can even go for several steps further and actually gain some insight into the character or the capabilities of the person who perpetrated that crime. That's a scientific enterprise. That's a scientific activity. Or what about SETI, the Search for Extraterrestrial Intelligence? That's an intelligent design program where astronomers think they can distinguish between a natural process source for electromagnetic radiation at some distance and electromagnetic radiation emanating from an intelligent civilization. That's intelligent design. Or archaeology. Scientists can pick up a rock and tell you if that rock was shaped by natural processes or by some creature like Homo habilis or Homo erectus, an intelligent agent that purposely manipulated that rock to create some kind of stone tool. And what I'd like to do is spend a few more minutes talking about how archaeologists actually go about detecting intelligent agency by looking at something called the Sereti Mastodon site. And by looking at what was done at this site, we actually are laying the groundwork for how I'm going to methodologically develop my case for a creator. Now, this site was discovered in 1992 in San Diego County, not too far actually from where I live. And Caltrans was doing road work and unearthed the remains of a mastodon, and of course that brought the work to a halt, and in come a number of scientists to study the mastodon site. And they concluded that these mastodon remains were manipulated by human beings. And at that time they assumed these were modern humans that had arrived across the Bering Land Bridge, 15,000 years ago or something like that. And when they looked at the site, they could see evidence for the mastodon femurs being processed to extract the marrow from the fresh femur. Now, they couldn't date the site at that time. And in 2017, probably close to 25 years after the site was discovered, people finally figured out how to date the site. And to everybody's shock, the site dated at 130,000 years in age. Now, if that date is correct, it means that there were creatures in the Americas about 115,000 years before modern humans made their way there that were actually living in the Americas. And the prime candidate would have been Neanderthals. And so people on this basis of this find believe that Neanderthals were actually in North America well before modern humans were. Now, this is an incredibly controversial claim that is literally overturning standard ideas in anthropology. Now, that's not the point, though. The point is, how did these scientists defend this claim? Well, this is how they defended the claim. Is they first established unequivocally the appearance of design. And they did this by noting that the arrangement of the bones and the rocks that were manipulating the bones was a non-natural arrangement. It looked like it was designed. Moreover, they saw markings on the rocks and markings on the bones that looked as if the rock was intentionally used to strike the bone. And so this was essentially evidence for design, that the site was manipulated by an intelligent agent. They also eliminated other possible explanations, like scavengers. Could the mastodon remains have been scavenged by some kind of wild animal after the mastodon died? They couldn't build a case for that, so they eliminated what we would call a natural process explanation. And then finally, they went into the laboratory and they took the femur of a cow and a femur of an elephant, and they struck those freshly harvested femurs with rocks, with the same kind of rocks that were at the site. And they showed that they could reproduce the markings on the bone and the markings on the cobble or on the rock. And so by creating in the laboratory those same effects, they could essentially show, again, the case for Neanderthals in North America. And so this is going to be how we're going to argue for a creator tonight, is that we're going to demonstrate that there is the appearance of design in biochemical systems, and we're going to go beyond just simply saying it looks like it's designed and actually construct a formal argument for design, looking at the appearance and the features of biochemical systems. We're then going to talk about the fact that chemical evolution, which would be the natural process explanation for biochemical systems, fails to account for those systems. And then finally, we're going to show that that when we go in the lab and we try to recreate life in the lab, it requires intelligent agency. These are the three criteria that the archaeologists used at the Sereti Mastodon site. So we're following in the footsteps of these archaeologists as we're making our case. Okay, and then finally, just as a bonus, I'm going to also talk about the fact that a design approach to biology, a creation model approach to biology, is actually a fruitful way to approach scientific discovery and investigation. Because many times the concern is that if we embrace the idea that the origin of life or the design of life is the handiwork of a mind, that somehow is going to interfere with science. It's going to get in the way of scientific progress. And what I'm going to argue is that this particular framework actually is productive in terms of driving scientific advance. Okay, let's take a look at the case for the appearance of design. One of the things that I find really astounding as a biochemist is that the defining features of biochemical systems, their hallmark characteristics, are identical to those characteristics that we would recognize as evidence for the work of a human designer. In other words, when human beings design, when we create, when we invent, when we manipulate systems or objects or devices, we produce systems that have certain properties that clearly reflect the work of a mind. And in fact, when we look at biochemical systems, what we see is those identical properties, those identical characteristics. And so by analogy, if certain properties are reflective of the work of a mind, and we see those properties in biochemical systems, that suggests that they too are the work of a mind. And then on top of that, there are biochemical systems that bear an eerie resemblance to man-made designs and man-made systems, where these biochemical systems are direct analogs to the types of things that we would build as human designers. And this allows us to revitalize or to revisit, if you will, the watchmaker argument for God's existence. You guys remember the watchmaker argument for God's existence? It's a rather simple and straightforward argument developed by William Paley in the late 1700s, where Paley, in his day, viewed a watch, which was one of the pinnacles of engineering accomplishment, again in his time, as clearly being an object that was produced by a mind. And so Paley argued that when you look at a watch, it has certain characteristics that reflect the work of a mind, and that the explanation for a watch is qualitatively different than the explanation for a rock. And so he argued that while a rock could be accounted for through natural processes, a watch can't be explained in that way. It requires a watchmaker to account for it. And then Paley surveyed biological systems and what was known about them at the time, and noted that those systems are much more like a watch than they are like a rock, and therefore concluded that biological systems must require a mind, a divine watchmaker, if you will. And this is essentially the same type of reasoning that we're able to reapply to insights into biochemical systems. But the case that we can make today is far more provocative than what William Paley was able to make in his time. And I'm just going to illustrate very briefly, one way that we could make a watchmaker argument. But there's literally hundreds and hundreds of distinct watchmaker arguments we can make looking at biochemical systems. But the one that kind of blows me away has to do with the DNA molecule. DNA is an information harboring molecule. It's a molecule that is built from discrete subunits, and those subunits, the sequence of those subunits, constitutes information. So you can think of it as digital information in DNA. DNA also has analog information with respect to its three-dimensional structure, but that's another conversation for another day. But DNA harbors digital information. And it turns out that the cell's machinery that manipulates DNA during DNA replication or processes like transcription or DNA repair are literally functioning as biochemical Turing machines manipulating the DNA. And if any of you know anything about computer science, a Turing machine is a theoretical abstract machine invented by Alan Turing, the father of computer science. And in fact, that's the foundation, that's the theoretical foundation for how computer systems operate. And when we're looking at biochemical systems, they literally are Turing machines that are manipulating DNA. In fact, the similarity between what's happening inside the cell and what's happening in the operation of computer systems is so stark, that similarity is so stark, it has actually given birth to an area of nanotechnology called DNA computing, where scientists are literally building computer systems using DNA and the enzymes inside the cell that manipulate DNA. And these are in little tiny Eppendorf test tubes that are this big. And a typical DNA computer is far more powerful than the most powerful silicon based supercomputer system that's been developed. In fact, that would be at Oak Ridge National Labs where we sort of visited a couple of days ago. But the point is that these computer systems are incredibly powerful systems. And this is a picture of Leonard Adleman, who is the father of DNA computing. He's a computer scientist at the University of Southern California. And his idea for DNA computing came one evening when he was reading a molecular biology textbook for fun and realized that, again, these enzymes are Turing machines. And this is what Leonard Adleman says. And think about the watchmaker argument in light of what Adleman is saying here. The most important thing about DNA computing is that it shows that DNA molecules can do what we normally think only computers can do. This implies that computer science and biology are closely related, that every living thing can be thought to be computing something, and that sometimes we can understand living things better by looking at them as computers. So again, this to me is not only the intuition of design when we're looking at biochemical systems, but we can literally construct a formal argument for design following in the footsteps of William Paley. Now, when you make an argument like this, like a watchmaker type argument, the immediate rebuttal, of course, would be the blind watchmaker rebuttal. The idea that, yes, indeed, biochemical systems appear to be designed. Nobody's disputing that. What is being disputed is the source of that design. Is it a mind or is it mechanism? And many people in the scientific community would argue that natural selection can function as the watchmaker. And this is what Richard Dawkins says in his book, The Blind Watchmaker. Paley had a proper reverence for the complexity of the living world, and he saw that it demands a very special kind of explanation. The only thing he got wrong was the explanation itself. The true explanation had to wait for Charles Darwin. Natural selection, the blind, unconscious, automatic process, which we now know is the explanation for the existence and apparently purposeful form of all life, has no purpose in mind. It has no mind and no mind's eye. It is not planned for the future. It has no vision, no foresight, no sight at all. If it can be said to play the role of a watchmaker in nature, it is the blind watchmaker. And so this is the rejoinder to the watchmaker argument. And that brings us to the second plank in our argument, and that is, can chemical evolution, or the origin of life process, or abiogenesis, however you want to frame it, can that produce the design that we see in biochemical systems? Because this, when we're talking about biochemical systems, this is where the blind watchmaker mechanism has to operate. And I'm going to argue that the answer is no. That the origin of life problem has been investigated for probably close to 70 years now, and people have yet to produce a viable explanation for the origin of life. There's been all kinds of ideas that have been proposed, all kinds of experimental work that's been done, but we're no closer to understanding the origin of life today than we were 70 years ago when Stanley Miller did his famous spark discharge experiment that launched origin of life as a scientific discipline. And in fact, the three main approaches to the origin of life are called replicator first, metabolism first, and membrane first scenarios. We don't need to know the details, other than these are three fundamentally different ways to try to tackle the origin of life problem, and all of them lead invariably to a dead end. Leslie Orgel, who when he was alive was one of the godfathers in origin of life research, said at a lecture, after delivering a lecture where he went through all the problems with replicator first scenarios, he said this: it would be a miracle if a strand of RNA ever appeared on the primitive Earth. And again, Orgel was a committed atheist and deeply committed to an evolutionary explanation for the origin of life. But in an honest moment, he had to acknowledge the very serious problems with replicator first scenarios. Orgel also commented on metabolism first scenarios where he made a similar kind of statement. These require an appeal to magic, a series of remarkable coincidences, a near miracle. Now, I want to be very careful not to put words into Orgel's mouth. Leslie Orgel was not arguing for intelligent design in any way, shape, or form. He was, again, deeply committed to an evolutionary explanation. But what he was acknowledging was the fact that nothing that the origin of life research community has tried has led to any kind of genuine progress. Now, a few years ago, when it comes to membrane-first scenarios, a chemist by the name of Jackie Thomas and I actually critiqued the membrane-first scenario. And we published our critique in a journal called Origins of Life and Evolution of Biospheres, where this was a peer-reviewed journal reviewed by origin of life researchers who agreed that our criticism of these class of models was actually legitimate criticism. And so the bottom line is we cannot explain how life originates through chemical evolution. We can't. Chemical evolution will not serve as the blind watchmaker. Now, when I presented this point to origin of life researchers and other people who have a scientific background, they will almost always agree. It's true, we don't know how life originates, but we think we have some clues because we are able to go in the lab and we're able to do simulation experiments that simulate different steps that we think may have taken place in the origin of life process. This is called prebiotic chemistry as a scientific discipline. We've been able to make building blocks for life. We've been able to assemble those building blocks into biopolymers. We can evolve those biopolymers in the lab into a wide range of functional enzyme-like materials. We can generate self-replicating systems. We can manufacture protocells. And so they'll say that, again, we don't know how life originates, but this is intriguing. It's suggesting that maybe, just maybe, there might be an explanation when it comes to chemical evolution. But I would actually argue that, ironically, this work that's designed to buttress to buttress the origin of life explanation actually provides evidence for the work of intelligent agency. Why would I say that? Because when you look at the work in prebiotic chemistry, that work is again, very impressive work, by the way. But you have these researchers that are in the lab setting up an experimental apparatus. They're adding the just right type of solvent. They're getting it at the right temperature, the right pH. They're adding the right materials at the right times with the right order of addition to produce the right concentrations that will allow for that chemistry to take place. They're very careful to exclude any kind of interfering materials that would disrupt that chemistry. They're stopping the reaction at the just right time to keep it from going too far, producing undesirable end products. In other words, the researchers have involved themselves to such a degree in the experimental design that they are actually responsible for the success of the experiment. That is, if it wasn't for their intervention as intelligent agents, that chemistry would not happen in the laboratory. And now when you think about what has to happen under the conditions of the early Earth, you have these uncontrolled conditions in a very chemically complex environment where the concentrations are going to be incredibly low, and there's no way that in that environment the chemistry in the laboratory is going to be productive on the early Earth, because you don't have organic chemists on the early Earth to superintend the processes. And let me illustrate this by talking about something called the RNA world. This is an example of a replicator-first scenario, and we're not going to get into the details of this, but the idea here is that the very first biochemical systems were built around the RNA molecule. Now, if this is going to be a valid explanation for the origin of life, then one of the things that you have to do is to show how RNA molecules could be assembled on the early Earth. And in the 1990s, there was a series of experiments done by a chemist by the name of Jim Ferris, who went in the lab and he took an aqueous system and he added clay to it, and he showed in that system the clay could actually concentrate RNA building blocks, elevating the local concentration very high, and because clay has a chemically active surface, could function like a catalyst driving the formation of RNA molecules from the building blocks. And this was heralded at that time as being a significant advance in the RNA world scenario. That this was considered to be a very important piece of evidence that supported the RNA world idea. The problem is that when you look at these experiments, you see that right away, these researchers are using chemically pristine sets of conditions. The water has to be pure water that they're using in these experiments. If it's not pure, the reaction doesn't happen. They were very careful to exclude different types of ionic material that would have been present on the early Earth that would have actually promoted the breakdown of the RNA chains as soon as they formed. They were careful to exclude organic materials that would have been present on the early Earth that would have actually interfered with the formation of the RNA chains. They also stopped the reaction before the RNA molecules got too long, because if they got too long, they would become irreversibly bound to the clay surface and wouldn't be available for the origin of life process. And then finally, to get this experiment to work, they had to buy the clay from a particular supplier that got the clay from a particular location, and then in the laboratory they had to treat the clay in very special ways in order for it to function as a catalyst. And they had to chemically modify the RNA building blocks so that they would be excuse me, more reactive. Otherwise, they wouldn't react to form the RNA polymers. In other words, intelligent agency was vitally critical for this experiment to work. This is what Simon Conway Morris has said. He is an evolutionary biologist. In his book, Life Solution, excuse me, said this: many of the experiments designed to explain one or other step in the origin of life process are either of tenuous relevance to any believable prebiotic setting or involve an experimental rig in which the hand of the researcher becomes, for all intents and purposes, the hand of God. And so, in other words, what this work is in prebiotic chemistry has shown is intelligent agency is critical for the origin of life. So what have we done? Well, we've done the same thing excuse me, that the archaeologists have done at the Sereti Mastodon site. We've shown that there is an appearance of design. In fact, we've gone one step further and constructed a formal design argument following after the watchmaker argument. We've argued that every attempt to explain how that design can originate through chemical evolution fails. And we've shown that creating life in the laboratory requires the work of intelligent agents. And these three lines of argumentation, I think, collectively demonstrate that life comes from a mind, can constitute evidence for a creator. Now, one other thing that I want to point out is this, that intelligent design is not only part of the construct of science, but can actually serve as a productive framework to drive scientific discovery and technology advance. Synthetic biology and biomimetics and bioinspiration are two of the hottest areas today in technology. And these are intelligent design programs, though they would never be labeled that way. Synthetic biology is trying to create artificial, non-natural organisms. And some of that work involves trying to create protocells. Some of it involves taking existing organisms and re-engineering them into new life forms. But either approach is essentially an intelligent design research program. Biomimetics and bioinspiration involve studying biological systems or biochemical systems, and then taking what is learned from those systems and using it to produce new technologies, either by directly copying biological designs or by using the insights from those designs to drive new technology. And to me, biomimetics and bioinspiration are incredibly provocative, because not only do they highlight the elegant designs of biochemical systems, but they also, I think, raise a significant challenge to the blind watchmaker mechanism, a distinct challenge that is separate from the challenge that we talked about with regard to chemical evolution. And it has to do with the fact that biomimetics and bioinspiration, while it naturally fits within an intelligent design framework, fits very awkwardly in an evolutionary framework. Why is that? Because evolution's mechanism is one that is unguided, undirected, it's blind, it's historically contingent based on a sequence of chance events where existing designs are repurposed to create new designs. And that kind of creation process does not generate optimal systems. It generates fundamentally flawed systems. This is what Ken Miller has said, a biologist. Evolution does not produce perfection. The fact that every intermediate stage in the development of an organ or a biochemical system must confer selective advantage means that the simplest and most elegant design for an organ or a biochemical system cannot always be produced by evolution. In fact, the hallmark of evolution is the modification of pre-existing structures. An evolved organism, in short, should show the telltale signs of this modification. In other words, evolution produces kludged systems, to use a term that we used when I was growing up in West Virginia. Evolution produces kludge jobs. It doesn't produce these elegant systems. Yet, what we see with biomimetics and bioinspiration is the fact that we can systematically go to biology time and time again and copy what biology does to create new designs. This is telling us that these are not kludged systems, but optimal, elegant, ingenious systems. Moreover, if they were really the product, again, of this blind watchmaker mechanism, why on earth would anybody in their right minds want to even go to those systems to look for inspiration? And so to me, the work in biomimetics and bioinspiration represents what I believe to be a distinct challenge to the blind watchmaker mechanism. Okay, so this is, again, in summary, what we've argued this evening. That we can make a case for a creator that, again, is a multi-pronged argument that is built from the same kind of methodology that an archaeologist would use to establish the work of an intelligent agent at an archaeological site, and that I think we can make a scientific case that indeed a creator does exist. Okay, so that is all I'm going to say. Now it's your guys' turn to ask questions, to raise points of dispute, to have at me, I guess, right? So we're going to turn the floor over to you to have a chance to engage with me. And what I'd like to do is, this is going to be an informal time. The hope is to have a lot of fun doing this. This isn't meant to be, adversarial. It's meant to be fun. We can challenge one another and that type of thing, but let's do it in the spirit of civility and the spirit of having some fun this evening. And then also, what I'd like to do is ask that if you've got several points or several questions that you want to raise, let other people ask questions or raise their points as well. So raise a point and then let somebody else have a chance, and then we'll come back to you if you've got other points to make, okay? So let's try to make sure everybody gets a chance to be involved if they so want to be. Okay, anybody got a question, comment? Yes, in the back.
Yeah, I got here a little late, so I missed a lot of this. Whenever you were speaking about there being evidence for a creator, are you speaking from a Christian perspective, or?
Well, yes, I am, because I'm a Christian, so I'm speaking from a Christian perspective. But in a sense, the argument that I'm making at this point is just simply arguing for there being a mind that's responsible for the design of life.
Okay.
To me, I don't think this evidence necessarily allows you to conclude that it's the God of the Old and the New Testament, but rather I think it just tells you that there's a personality that's behind everything.
Well, that leads me into my next follow-up. other religions like Shintoism or other religions that don't really worship like an anthropomorphic or humanoid type God. They believe like in more of an energy or a consciousness. And some people have transferred that theory into, I'm sure you're aware of like the Higgs field,
Right.
and how things that come in and out of it, and it creates and destroys. What is your opinion on the Higgs field in relation to your theories about there is being evidence of a creator? Do you see that as being further evidence of there being a creator?
The short answer to that question is no. Now, I think the idea, what you're talking about is an idea that would probably support deism, where there's a kind of a force that's behind everything, but that force may be impersonal, right? So I think you could use that kind of argumentation to support deism. But in my view, when you're talking about design is something that comes from a personality. So I think by making the argument for a mind here, it's not a mind that is akin to an impersonal force, but rather a mind that would be emanating from a personality. And to me, this argument is an argument for a creator, but to flesh out who or what that creator might be, I think there's other information that we're going to need to use. And so, for example, if you look at cosmology, it looks as if at least the local universe that we're a part of has a beginning, which means there must be a cause outside the universe that brought the universe into existence. So theological language would be that that's a transcendent cause, right? We see constancies in the laws of physics. That tells us something about the nature of that transcendent cause as well. Not only do we see design in biochemical systems, we also see design in the universe itself. And so the fact that we're seeing design, that is characteristic of not only the universe, but living systems and a transcendent cause, that now is telling us that personality is probably a super person, or a super personality, right? And so, that at that point is consistent with the God of the Abrahamic religions. And so to me, then, the case for Christianity, if you're going to, again, make a kind of a bottom-up case, would be now looking at the historical evidence that one could make for the resurrection of Christ. So to me, you're not at that point, you're moving away from a scientific argument into a historical argument. But I would maintain that when you couple the insights from cosmology with the insights from what we see here in Origin of Life and biochemistry with the historical evidence, you've got a really robust argument that it's likely the God of Christianity that we're talking about. But I would agree that this particular argument that I'm presenting isn't sufficient to draw that conclusion. It's other information that we have to add to it. Yes.
Yeah. So first, I guess, or could you maybe bring up a picture of one of the proteins that you showed me?
Oh.
Yeah, like for instance, this. And I'm just curious, actually, what protein is that?
I don't know what that protein is. It was a cool picture that I pulled.
So I'm actually a biomedical sciences PhD, and so I kind of share this, it's so fascinating and life's so complex and amazing, and I feel like we vibe on that. And I actually really do appreciate that you did pick a protein that kind of looked like this, because there are some proteins I think look more structured and almost more designed, I guess, but I feel like most proteins that I see are more like this, just kind of globular in the cytoplasm. So I appreciate that you use more of a representative picture than something that would be kind of staring the audience in the wrong way, I guess. But does anyone think that this looks designed, actually? this protein?
You mean visually or
Yeah.
what it operates?
Visually.
I've seen some crazy machines where the ball drops down, tips over some dominoes.
Yeah.
I see pipes.
Yeah, and typically proteins like this work in that they have like a single little pocket out of this entire protein where something binds and then makes a conformational change that facilitates changing into something else. But I mean, essentially, I think this is an example of just, I forget what word you used, it was kludged? Kludged, oh, okay.
It's a kludge.
Yeah, but like, I feel like there is a lot of instances, like proteins like this that have a single little binding pocket in it, and the rest of it's, I mean, it helps its function, I suppose, but, and you said that, like, one example of design is irreducible complexity, but there's just so many instances, like proteins and even in, like, macro for our bodies, like appendixes and our tailbone, that just could be reduced if it was really designed optimally.
Yeah, well, okay, let me respond to your comments, and then
Okay.
I'll give you a chance to come back if you'd like. To me, I'm actually really sympathetic to the points that you're making. I think, from my perspective, biochemical systems, I think, represent a very fertile ground to make a very robust design argument. But what I see oftentimes being done is people being very sloppy in terms of how they're thinking about biochemistry and how they structure the argument. So to me, it's not pulling out one particular system and say, okay, on this basis of this system, we're going to make the argument for design. But to me, it's the totality of what we see in biochemical systems. And it's not just a single attribute, but it's a combination of attributes that collectively make that argument, right? And so to me, I wouldn't necessarily focus on this, although I would argue that typically what you see with proteins is that they are, I wouldn't say fine-tuned, but they're high-precision systems that typically are highly optimized. Now you could argue that natural selection could create that optimization and that high precision. So I wouldn't rest the argument there, right? But you could at least say, while it doesn't superficially look designed, when you look at, you know, the structural features in detail, there are features in it that you could conclude or would suggest that these systems are designed, right?
I wouldn't.
Well, optimization and fine-tuning are high precision systems, are characteristics of human designs.
I mean, it's not just a characteristic of human design, though. I mean, there's plenty of instances where, I mean, even directed evolution in today's studies, where all you're doing is really just selecting for things that do something, which is essentially all that, at least, evolution.
Right, but again, what I'm trying to get you away from is fixating on one or two attributes. With the idea of irreducible complexity, to me, the way that argument is used, typically, I don't think is a sound argument. Because the argument is biochemical systems are irreducibly complex, and evolution can't generate that, therefore they're designed. I think that's a really bad argument, because I think irreducible complexity, like optimization, like high precision systems, can be generated by evolutionary mechanisms, or at least there's proposed mechanisms for how that could be done. It's through co-option or exaptation. But again, I would argue that systems that are designed also display those kind of properties. Irreducible complexity, they display optimization and fine-tuning. So in other words, in the philosophy of science, there's this idea that theories are underdetermined by data, which means you can have the same set of data that can be accounted for by two very different theories. And so what I'm saying is that those properties can be accounted for both evolutionary mechanisms and through design. So it's really a toss-up. To me, where the case for design becomes more and more provocative is as you start stepping through other qualities that you see in biochemical systems. For example, to me, where you've got, I think, beginning to see a problem emerging is the number of chicken and egg systems that you see in biochemical systems. And so, for example, protein synthesis is the queen mother of chicken and egg problems, or chicken and egg systems, because you have to have proteins to make proteins. And the proteins, of course, are part of the ribosome, but they're part of the, if it's a eukaryotic system, the spliceosome is part of the transcriptional system, and the chaperones. So you've got to have proteins to make proteins. And the problem is that, let's say, you can't boot up that kind of system through an evolutionary stepwise manner. So let's say you've got a ribosome that is produced from proteins that are very early in an origin of life process. Right? Those proteins are not going to function very well, right? And so what's going to happen is that ribosome is going to be relatively inefficient and is going to make proteins that are going to be error prone, which means that the next wave of ribosomes is going to actually be more error prone, they're not going to be improved. So you're going to wind up in this auto destruction cycle that you can't get out of. And so to me, with a chicken and egg system, that's a prime example of where I've not seen anybody suggest a reasonable explanation for how that kind of interdependent system, where the system depends on itself to exist, or a chicken and egg system could come into being from an evolutionary perspective. So I think you're beginning to separate those two models there, or if you're looking at what I think to be a serious problem, which is biochemical convergence, where it looks as if, from an evolutionary perspective, biochemical systems emerge independently multiple times. And in my book, The Cell's Design, just for fun, I catalog 100 examples of molecular convergence that you see in biochemical systems. And I could have done probably, several hundred more if I wanted to. But for example, the mechanism the system that replicates DNA in archaea in bacteria is identical systems. The mechanisms are identical, and yet it looks as if those systems actually emerged independently 2 separate times. And when you look at the nature of the evolutionary mechanism, it's historically contingent, and the expectation is the outcome is not going to be the same.
To go back to the chicken and egg, sorry, because I will go to the same. But it is kind of interesting, though, because the proteins that you mentioned that are kind of the key chicken and egg problems, the ribosomes and the spliceosome. It's interesting because a lot of their ribonucleo, I forget the exact term, but essentially a lot of it's RNA in those proteins, right?
Well, the ribosome, the catalytic, the portion of the ribosome that is catalyzing the formation of the peptide bond is a ribozyme. It is RNA. Exactly. But those other proteins that are part of the ribosomal complex are actually critical to be there.
Yeah, but you can imagine, though, since the critical thing was an RNA, that it could have initially been just an RNA that by itself worked, and then created proteins without needing a protein to begin with, and then just proteins after that happened to be able to assimilate into it to make it better, and then that was further optimized to the point that it no longer worked with the initial system of just the catalytic site with just the RNA.
Yeah, but if those proteins are playing any kind of role in that emerging system as you're transitioning from the RNA world to the DNA protein world, if that ribosome or that pre-ribosome-like structure isn't functioning with a high level of optimization, you're still going to wind up in this auto destruction cycle. Because, right,
I can still see it be like a stepwise manner, but I don't know.
Well, let's put it this way. I've not seen anybody come to the table and produce even a plausible pathway for how something like that would take place. So, You know, so in other words, I don't think that, I don't think, because you can always say, well, there might be a way to do this, but that really is kind of appealing to a future discovery or a future insight that hasn't been yet produced, right?
Yeah, but I'm sorry, I know I'm taking up a lot of time, so I'll try to stop soon. But just because we don't understand a way it could happen right now doesn't mean that it couldn't exist naturally. I mean, just in general.
Well, and that's true. So in both instances, but now our conversation is engaged in what we're hoping will happen or what we think might happen in the future of scientific discovery, as opposed to saying, here's the evidence in front of us right now, and what kind of conclusion can we draw? And you know, as I pointed out at the beginning of the talk, I came to this conviction about 33 years ago when I was a graduate student, and for the last 3 decades, I've been revisiting this question, and I just think the problems for chemical evolution have become more and more significant, and the evidence for design is becoming more and more prominent. So I see the trend line, again, moving in favor of the design argument. But my larger point, again, to you, and then we'll let somebody else, my larger point is that I'm not making an argument based on a single feature of the cell, but it's collectively, the collective features that you see that are hallmark characteristics of biochemical systems, plus those systems that, again, bear a similarity to man-made designs, that's the entire package that I think it's a weight of evidence as opposed to focusing on a single individual feature. Right. Let me take this gentleman here, then I'll take you next.
I appreciate that, and just to continue what he was saying, because I'm just a little trial lawyer, but which may or may not be valid at this point. But the point I was going to make was the first point I was going to make was for 10,000 years we tried to fly, and people said if man was going to fly, he'd be given wings. Well, that didn't happen. We had Orville and Wilbur Wright in Ohio who did it. That's just one point on that line. The other was more. This is getting a little more mechanical. Speaking of mechanistic, and that's the Cerruti Mastodon site you were talking about. And I apologize. I should have spent some time looking at this. I didn't. Do you know what kind of dating system was used to come up with 130,000 years?
Yeah. Good grief. It was.
Usually it's argon at that kind of distance, but
Yeah. It was some kind. It's a relatively new uranium.
it's not thermoluminescent.
No. It's a uranium. It's a uranium isotope method. I'm drawing a blank now. This specific method.
I started blank, so you're better than I am.
Yeah. It's a relatively new variation of some kind of uranium isotope dating method. Now, to be fair, that conclusion that Neanderthals were in North America 130,000 years ago is highly controversial, and it's contended. It's contended right now. So. It may not stand up. In other words, it may not stand up. So my point isn't that whether the conclusion is ultimately valid or not. My point was that this is kind of the way. This is laying out a way to think about the problem, right?
Right, but to think about it, you need to know, for example, what lithic system was used. What kind of when you're talking about cobbles, there are cobbles that were used by Australopithecus, but not by Neanderthal. Neanderthal had a fairly sophisticated toolkit, including some hand axes, which were pretty impressive. And
well, that's actually one counter argument that's being made to Neanderthals actually carrying out that work, is that the tool or the cobbles don't look like what you'd expect Neanderthals to use based on what you see in Neanderthal sites. So.
What you're referring to sounds like Australopithecus rather than Neanderthal. But there's also Homo erectus in there who had its own toolkit.
Right, and although I don't think Homo erectus would have been. I think the reason why people argued it was Neanderthals was, number one, it was 130,000 years ago, and so you did have Neanderthals in Siberia. I think by that point, if you had erectines around, they probably would have been on the cusp of dying out, but I don't think
They're still there.
well,
You still find them at 130,000.
maybe not. But I don't think they were as far north, even if they did exist, I don't think they ever were as far north.
Well, they got all the way to northern China.
Yeah,
And
well,
that was colder than blue blazes there.
Well,
Whether they got through Siberia is another issue. You're
right. Well, again, my argument doesn't rise or fall on the identity of the creatures at the Sereti site. It's basically this is the methodology that these archaeologists used to establish their case.
Well, essentially they use scientific method and inductive logic, don't they? Isn't that pretty much the way it works?
Right, and so that's what I was doing was.
Yeah, and they always go by probabilities rather than coming up with a concrete method, except some anthropologists. Don't.
Yeah. I mean, to your questions, I mean, what's going on with the Sereti site is extremely fascinating. It's controversial to be certain, and I'm not saying that that anthropologists are necessarily accepting this work, or that there's not room to criticize the work or the conclusions that these researchers drew from the site. But it's very clear that something was manipulating those mastodon remains. And
you can get marks like that though from saber-toothed tigers and from leopards and some other animals. That's one of the things that they have to be able to factor out before they come up with a conclusion.
And in the paper they did do that. And so I don't know. Right, and that was actually part of why they went in the lab and they tried to replicate so the fact that they were able to replicate it by by actually processing the fresh
the other femurs.
Yeah.
I'm going to let somebody else go, but with your permission, I'd like to ask a couple more that are a little more direct. But I just wanted to get this down for them.
Sure. Yes.
So I say, first of all, thank you very much. I thought this was a pretty good and lucid presentation, so I appreciate that. Thank you. I think my questions come from more the structure of your argument. So in its current state, I think your argument is those first 3 points on the slide right now. So it seems like that is fairly vulnerable to future discovery. That possibly there was maybe some other mechanism to explain the origin of life, or we were able to find some instance in nature where intelligence was created through natural processes. So it seems like it's vulnerable to future discovery. So I guess my question is, if those the second and third bullets were to fail, how does your argument stand then?
If the second or third bullets were to fail?
Let's just hypothesize that future discoveries just firmly dispute your second and third bullets. How does your argument stand?
I think the argument becomes very weak.
Okay.
Right. Yeah. Because it's not. In this day, when Paley was advancing the watchmaker argument, this was prior to Darwin, right? And so, in and of itself, at that context, the argument was compelling. And in fact, Darwin himself was taken initially as a young man with Paley's line of reasoning. And so, it's really the Darwinian revolution and Darwin's claim that, that natural selection can function like the watchmaker that really undermined Paley's argument. And it's very interesting, I'm not sure if you're aware of this, but when Darwin wrote Origins of Species, that book is actually a response to natural theology. That he actually wrote it as a response to Paley's natural theology. In fact, Paley has a chapter in natural theology where he talks about the camera eye of a vertebrate. And when Darwin talks about organs of extreme perfection, and he talks that classic passage where he talks about how the eye of a vertebrate could evolve, he's literally offering a rejoinder to Paley at that point. Because Paley made the claim that if the only example we had was the vertebrate eye of a camera, then on that basis alone we could conclude there was a mind. And so Darwin is offering a rejoinder to that. So to me, I think that second component is actually a critical component to the argument. And I think the third argument about creating life in the lab, I don't know if that argument, I don't know that argument necessarily, if it failed, would undermine the argument if the second one wasn't still in place.
Okay. So do you think, kind of comes down to the second, kind of explaining the origin of life? It's kind of what it comes down to?
Well, no, it's more than that, because I wouldn't say that, I mean, my argument is not a God of the gaps argument, right? In other words, I'm not saying because we can't explain the origin of life, therefore God must have done it. What I'm trying to do is say that's a component of the argument, but to me it's absolutely critical to establish some kind of case for design. There's a number of people that have tried to come up with design criteria. In my book, The Cells Design, I talk about intelligent design patterns. Bill Dembski talks about specified complexity. Doug Axe talks about functional coherence. But everybody is essentially describing what Paley described, which was a term that he used called a contrivance. So everybody is essentially restating Paley's argument. But I think it's a powerful argument in this, that we are very good at looking at things and telling whether it's designed or not, even if we have no idea what the purpose of that system is. And it's not just intuition, but rather I think in our minds we just see what Paley would call a contrivance, where things are interacting in a precise way to accomplish
But isn't that
purpose.
kind of another way of saying intuition?
What's that?
Isn't that kind of another way of saying intuition?
No, I mean it's a criteria. I mean it's
That we just kind of look and know?
well, like for example, what I laid out, where there's a list of properties, like with
Yeah, like irreducibly compact chicken and egg, things like that. Those are design criteria, I suppose.
Yeah. So in other words, let's start with Paley. Paley used this term contrivance, which he then defined. Right, it's a number of parts that are interacting precisely, framed together to accomplish a purpose. Right. That's how those are Paley's words. What I've done, I come along and I said, okay, here are certain qualities. So I've delineated qualities that you see in systems that we know are designed by human beings. And those combination of qualities reflect what I would call an intelligent design pattern. And so then at that point, in principle, you could mathematically apply that pattern to any system and do pattern matching, right? And you get a mathematical score for how closely does that pattern that you're evaluating compare to the intelligent design pattern. And from that, you could develop a quantitative criteria for whether or not it's designed. So I don't think it's intuition. I think it's actually, here's a set of qualities, and how closely does the system that we're looking at match that pattern or that template, right?
Yeah. So we've kind of looked at like human systems and kind of look at how those work, and then go apply those to nature, I suppose.
Yeah.
Well, couldn't it also be that we have developed those systems by observing nature, and so we're sort of kind of begging the question there? Do you see my point?
Actually, I don't think that would be correct. And this again is going back to the point that Paley is making with the watch, and that is when you look at a watch, there's something about it that is completely distinct from what we see in nature. So I don't think.
Well, one thing that would distinguish a watch from nature is that we've seen people make watches.
But that's not Paley's argument. Paley's argument is not that there must be a watch. I know that there's a watchmaker because I've seen people make watches. His argument is actually, when I look at the properties of that system, those properties. So a watch was the example, but he generalized from that example. These are the properties or the qualities that systems display when they are the work of a mind. And then when you look at biological systems, you see that, and he's very careful to say this is very different than what you see happening in nature with, for example, a rock. And let's take biochemistry. I mean, one of the features of life is that life is chemically distinct from the environment, that life displays an organization, and it's a homeostatic organization. So right away, living systems are not like the chemical processes that we see that in the non-biological realm. And this is actually how biologists would distinguish life from non-life, is that it displays organization, it displays chemical distinctiveness. And so on that basis right there, you're not looking at life being something that's mimicking processes in nature, right?
Okay.
So
I mean, so something like we can look at the watch and there's mechanisms about it that show that it's complex and it's organized. But we can also take something maybe like the development of a human being from like a sperm and egg cell. Something similarly complex, but we know the natural process that does that. It's not like someone goes in there and organizes our heart, organizes our lungs. It develops from a natural process. So in that case, couldn't we apply that same criteria to something that was naturally made and conclude that someone designed, human beings in a similar way that a watchmaker designed a watch?
well, and when I'm making this design argument, I'm not saying anything about how specifically the designer achieved the end product. And so you could say that design could be achieved through some kind of process that was put in place that would drive things to a particular endpoint.
So even if we have a natural process to explain all this stuff, you're saying that still would not suffice to defeat your argument?
No, I'm not saying that.
Okay.
I'm not saying, well, in other words, I'm saying that this, let me step back. To me, I think when we look at the work that's going on in prebiotic chemistry or in synthetic biology, what you have there is an example of what a friend of mine, two friends of mine, Dan Dyke and Hugh Henry, said is an example of hypernaturalism. In other words, when we go in a lab as organic chemists or as synthetic biologists and we're trying to create protocells or trying to run a chemical reaction that doesn't occur in nature, what we're doing is we're taking the laws of nature that exist and we are manipulating them under highly contrived conditions to affect a particular output or a particular product, right? So we are creating this non-natural, artificial circumstance that's using the mechanisms of nature to achieve an end goal. And so one way you could think about the origin of life process is that it's nothing in that God didn't, or the mind or God, or didn't just come in there and start zapping things into existence, but it could very well be that God worked within the laws of nature that he created, but he did it in a hypernatural way, where the things that resulted were due to highly improbable things that are happening at the just right time in the just right way to accomplish an output. That's just as, in my mind, as miraculous as God zapping life into existence. So to me, I think that would be the distinction I would make, right?
So then how then would I be able to tell the difference between a natural process that God is behind versus a natural process that God isn't behind?
That's a good question. Because in a sense, from a Christian perspective, you would say that God is behind everything that is happening within the universe, right?
Yeah, well, but I don't think we went that far.
Right. But to me, it's not a question of. I think the way you would distinguish that is, again, looking at the problem in chemicals, but looking at chemical evolution, because chemical evolution is essentially a process that presumably takes place in an unguided manner, right? Where it's just the molecules on Earth that are interacting and building up in complexity and interacting to form ultimately chemical super systems that assume the properties of life, and that this is happening in an unguided way. So if you could show how that could happen, then I think what you would have is an effective counter argument to what I'm making here, right? So you but the argument is predicated on the fact that we don't know if that is even possible, right? We don't even know if that's possible under the conditions.
I agree that we don't know if it's possible, so that I think that means that your second point isn't established. It's not, we shouldn't accept or reject it, it just hasn't been established yet.
I would actually say it's actually been, I think it's not that it hasn't been established. I think when you look at the last 70 years of original life research, I think in the fact that everything that people try winds up at dead ends, I don't think you could say that it hasn't been established or not established. I think it's really questionable in my mind if you're ever going to get there. I mean, the problems are highly intractable. Let's take somebody else. Eric.
I just want to join in with you guys. I really appreciate you being here and the things you're saying. Something I've heard Fuzz say before is, even as a Christian, the mindset he takes into a laboratory is methodological naturalism. He doesn't come to the lab and saying, hey, God did this. Or God, this couldn't have happened naturally. I think what you're saying is, when you chase down every decent, any, it's a bad word, but any reasonable, testable hypothesis for something interesting that we see in nature, we can get to a place where, with sufficient dead ends, not so much you prove conclusively that God is responsible, but you find yourself thinking, this isn't crazy to be thinking this anymore. I mean, I'm saying it's a viable thought, but in the end, but you don't go to the lab saying, let's discover God. You go to the lab applying the rules of naturalism. Let's assume naturalism. You want to have a testable, and so it's a methodological mindset that you have. So when I listen to what you guys are saying, I'm going like, yeah, but at some point, don't you get to a point? I don't know if you want to jump in on this, but you understand what I'm saying? Don't you get to a point where you realize, if I keep running to dead ends, is the whole idea of a Christian worldview, and again, in my personal life, I'm a scientist as well. In my personal life, there's my life outside of science. It sort of folds into this conversation as well. Sort of what I would call questions of value as opposed to questions of fact. And when I integrate how I explore questions of value with questions of fact, science, it does have it's like I can't compartmentalize myself that completely, Anyway, I think I said too much. But did I misspeak when I said that we talked about methodological naturalism? You're not saying God did it. You're just saying it's not crazy to suggest that there's intelligence in it. It's not crazy. Because I think sometimes when I talk to people about this, they think as long as I can come up with an idea that eliminates God, that demonstrates that God is an irrational response. I'm not really sure that's true. And to follow up on something else you said too, can you think of any theory that is not subject to future discovery to fail? Can you think of anyone that's like that solid?
The world being round.
The world being round, but then someone says, but that's not round, that's an oblate spheroid. And you go, okay, and so you're constantly redefining your words.
Yeah, but it's certainly not flat.
But why does flat have to be an alternative term? There's got to be other alternatives. So I feel like we're getting into nuanced language and getting away from a more important aspect of our conversation. Because I agree with what you're saying. But to say, well, let's subject to future discovery, I'm trying to think, there's a lot of things we talk about today and we realize the role of the next generation of graduate students is to prove us wrong. That's your job. And if you don't do that, you're not doing it right. Theories have to die. They have to. And the cyclical process never ends. But there is a process that seems to be moving in a general direction. And dead ends change that direction. That's what I'm thinking about this.
Well, thanks for those comments, Eric. And to me, I think, and then we'll take somebody else's, because this is fun. This is fun.
Oh yeah, I'm having a great time.
Yeah.
This is fantastic.
Yeah, but to me, I think, building a little bit off of what Eric said, to me, I think what you're looking at here with these three lines of argumentation is really a probabilistic conclusion. All right, I'm not trying to argue that this is a deductive conclusion. It's a probabilistic conclusion, And at this point in time, the question becomes, which is the most reasonable explanation? That we see design, we can't account for that design through chemical evolution, 70 years of work in chemical evolution. And when we go in the lab, it's very clear intelligent agency is critical to affect the transformations that we think are needed for the origin of life. So which is the most reasonable conclusion with those three sets of facts? I think at minimum, concluding that there's a mind behind everything is reasonable. It's a reasonable, rational conclusion that is evidence-based, right? Following again along the lines of how archaeologists would think. And perhaps it's is it a more reasonable conclusion than just simply a mechanistic explanation? That's really, I guess, a judgment call that you would have to, that each person has to make. To me, I think it's a more reasonable explanation, and it was part of what motivated me 30-some years ago to convert to Christianity, was I felt like that was the most reasonable explanation at the time. And I've gone back, as I said, and evaluated that explanation for 30 years. And to me, it seems more reasonable today than it did 30 years ago. But I think it's perfectly reasonable for someone to come up to think that the other explanation, that it's mechanistic alone, is a more reasonable explanation, because there's factors that you're bringing into it that are scientific and other factors that are not scientific. Just like I'm bringing in scientific and non-scientific factors as well. So it really becomes a question which is the most reasonable, right? So, all right, let me.
May I ask the first stupid question of the evening? I have that question, hopefully. Your talk tonight is why I believe in God. Let me turn it around and say, why should I believe in science? As far as the origin of life is concerned.
So why should you believe in the origin of life from a mechanistic standpoint?
Why should you? Well, that's fine. I mean, it seems to me that the evolutionary theory is that it takes you all the way back to what, a bacterium, and I think the first cause argument seems to blow a hole into that just by its very nature. But assuming that the scientist has some answers, what are they? What could they be? I mean, obviously you're arguing one side, but as a good debater, a good person to discuss this with, you obviously can take the other side. So explain to me, why should I believe in science when it comes to the origin of life?
Well, I mean, if I was going to argue for the origin of life, my primary argument would be what I showed right before I introduced the third point, which was we can go in the lab and we can identify chemical and physical processes that in principle could contribute to the origin of life. So that would be my argument. And because we can identify those processes, while we have no clue how they might even work on the early Earth, the fact that we know that those processes exist means that it's at least conceivable that chemical evolution could occur. So that would be that's how I would make the argument. And when I've interacted with origin of life researchers, some fairly prominent origin of life researchers with these kind of arguments, and to me, what I end up seeing to a person is this: that we agree we don't have an explanation for the origin of life. We think we have clues for how it may have happened, but we don't really understand how the origin of life happened. And you even see people occasionally make statements similar to Leslie Orgel, that Paul Davies in his book, The Fifth Miracle, which is on the origin of life, basically said this, and I'm paraphrasing: you would be forgiven if you concluded that life's origin was a miracle. But he said, but in science, we don't draw that conclusion. We look for mechanistic explanations. And so, to me, the two arguments I would make is that science is all about finding a mechanistic explanation, and we've got a few clues, and so therefore I'm committed to pursuing that particular line of argumentation, right? So that would be the primary argument for the other side. Would be the, at least that's how I would make it.
The way that you framed the issue would be the correct way, though. What's the most reasonable explanation? I seem to hear all the time how if you believe in religion of any kind, that it's anti-intellectual. But somehow if you're a scientist or if you're in the field of science, you're extremely intellectual. Just assuming for a moment, we can kind of test or delve into that, dig a little deeper. I ask again, if I wanted to believe in why I'm here, what does science tell me to do? What's the first step? How should I get into that?
May I respond to that briefly?
Okay.
In a way that's positive to what he was saying. I'm on the other side of this, but
Yeah.
science is a belief system, just like what you're talking about.
Yeah.
Like the Christian faith or any faith is a belief system. And what you have to do is to find out which belief system correlates the closest to what you believe personally. That's what it comes down to.
And there's some questions science can't answer.
Say again?
There's some questions science simply cannot answer. That's
Well, right now they can't, but they will.
okay, then there's the future stuff that we don't know. Sure has an awful lot of power.
Well, they just found that there were archaean animals alive at 4.1 billion years. So I mean, that's.
But you can't say all your problems will be solved in the future. I mean, I guess we can say it. I've probably said it 1,000 times myself anyway. But why does what we don't know have so much power? That really bothers me sometimes.
That's what led to religion in the first place, in my view.
That's
What we don't know.
Well, and I respect that. Thank you for telling me that. But I hear that very, very frequently. Someday we will do this. Someday we're going to do this. And because the people who say this are very optimistic and well-meaning people, I desperately hope they're right. I really, really do.
But we could be wrong.
I have to agree with that. In the absence of information, you can't make a choice about to go left or right.
It's pure speculation
You
at
got to
this
keep
point.
both hypotheses have to stay active in the absence of information.
I'm sorry, I didn't mean to spike this.
That's okay. I'm perfectly fine. Well, when I'll tell you a quick story. Then let's give a chance for someone else to ask a question who hasn't had a chance yet, and then if nobody else raises their hand, then people can come back for round two. But when I was doing my PhD defense, in the middle of the defense, two of my committee members actually got into an argument about a point in my PhD thesis where I answered a question and one person didn't think I answered it and the other person thought I did, and they argued for 30 minutes about it, and so that was really kind of nice when you're yeah. So if you guys want to argue among yourselves, I'm okay with that. I'll sit back and take a break.
Dr. Ron, I want to ask, it seems like your entire argument isn't an argument from analogy. And Jay mentioned something about probabilities earlier, and I'm wanting to know, since Hume dealt with analogies and supposedly squashed it, how do you respond to this idea that maybe your entire argument is kind of flawed because you're approaching it only from an analogy, or are you not? Maybe.
No, I mean, you're right. I mean, in a sense, it is, the first and the third point are basically making analogical arguments. And, I wouldn't say I'm a Hume expert by any means. I've read Hume, at least the dialogues on natural religion. And Hume's critique of the watchmaker type of reasoning, which is, as you're pointing out, Aaron, built on analogies, is that when we're drawing analogies, it's a probabilistic conclusion, and the certainty depends upon how similar the things are that we're comparing. The more similar, the more certain the conclusion, the less similar, the less certain the conclusion. So Hume never argued that analogical reasoning is faulty. It's just that you have to approach it in a careful way. And, and so taking Hume's lesson, that's why when I'm making with the first point, the similarity between biochemical systems and man-made designs, again, I used a single example, but in the book, The Cell's Design, I delineate, again, a number of properties that are characteristic of design systems and showed how those properties are manifested in a large number of biochemical systems. So I'm using a large number of examples and I'm using multiple attributes, all of which are relevant to the conclusion. Plus I'm comparing full-blown systems, that quality control systems or molecular machines or information systems and the codes that we see inside the cell to man-made systems, showing again those similarities. So the more examples you can bring to bear in analogical reasoning, the more sound the conclusion, provided that those examples are relevant to the conclusion you're drawing. And analogical reasoning is used in everyday reasoning. We use it well. We know how to use it well. It's used in science, it's used in legal reasoning. So there's nothing fundamentally wrong with analogical reasoning. It's just that we need to use it well. And again, it's analogical reasoning when we say, hey, if it requires intelligent agency in the lab to affect this step in the origin of life, it's not unreasonable to think intelligent agency was involved in the process. That's analogical reasoning as well. But
I mean, he was really successful at the time. Are you saying now because we know more about the biology that the arguments get his
well,
arguments?
I mean, what Hume's response was, or I've seen other people who follow in Hume's step respond to this argument would be, for example, well, let's take molecular motors. I mean, there are molecular motors inside the cell that are just eerie in terms of how similar they are to man-made machines. Like the F1F0 ATPase, for example, which is perhaps one of the most important protein complexes in biology. It's the one that drives the formation of ATP using proton gradients. It's essentially, you've got motor proteins that are powered by electrochemical energy. So it's kind of like an electrically powered rotary motor with a rotor and a cam, and there's a turbine and a stator. It's very much machine-like, and this is just one of probably 50, 60 examples of machine-like proteins that are similar and almost identical to man-made machines. And so to me, that makes a very powerful watchmaker argument by analogy. Now the rejoinder to that would be something that, for example, I've seen Massimo Pigliucci make, who's a philosopher of biology who is also an outspoken skeptic, atheist, agnostic. I'm not sure how he would categorize himself. No friend to the design argument. And he argues, well, when biologists are using this language, they really are using metaphors. These are really not machines. And this is essentially very much a Humean critique of the watchmaker argument, right? Where Hume was arguing, well, a watch and a biological system really aren't that similar to each other. They really are too dissimilar to draw any kind of conclusion about what a watch needs to explain its origin versus a biological system. So Hume really didn't undermine analogical reasoning. What he did is he challenged essentially the watchmaker analogy specifically. But to me, the response to Massimo Pigliucci's complaint, which again is very much following after Hume, would be to point out that people that are working in nanoscience are literally isolating these molecular machines from inside the cell and interfacing them into nanodevices as a way to power motion. So we have technologists that are literally using these machines inside the cell as machines in their constructs. And they're using them because they can't build the systems that can generate, controlled motion. Whereas these biochemical machines can do that. And they do it at near 100% efficiency. And so that to me is a very powerful rejoinder, I think, to that critique of the watchmaker reasoning, because you can't say that these are just metaphors for machines when we in fact are using them in that way. You could argue that they really are machines in light of those kinds of experiments. So to me, it's not that, again, analogical reasoning is somehow fundamentally unsound. It's Hume's critique really was Paley, or people like Paley who are making those kind of arguments are misapplying analogical reasoning, or they're not using it well. That really was Hume's critique. Okay, yes, sir.
If there is some sort of a creator that must understand us better than we understand ourselves, how come we come nearly at the end of all this time rather than way back near the beginning?
Well,
if you knew where you were going, why wouldn't you get there as quick as possible?
well, I mean, that really is a theological question, right? More so than anything else.
Then why would we still be such a mess?
Well, from a Christian theological standpoint, the reason why we're a mess has to do with our rebellion against our Creator, right? It's called sin, theologically speaking. That's why we're a mess. To me, I think an answer that I've heard to that question that I find provocative and compelling is an answer given by my friend and colleague Hugh Ross, who's an astronomer, and he basically points out that you really cannot have human life until the universe reaches a particular age, and this is because you don't have, first and foremost, the chemical elements that you need for life to be possible. So the first 10 billion years of the universe's history, you're probably not going to be able to support any kind of advanced life because the chemical elements that we need haven't even been formed or formed in the abundances needed for life to be possible. And even then, when you look at the history of the Earth, there are certain events that have happened that have actually enriched the Earth in certain materials that actually make the Earth a suitable environment for life. And then when you look at the history of the Earth, it's going to take time for the Earth to undergo transformation so that, first of all, advanced life is possible, and then human civilization is possible. And so Hugh argues that we are at that right point in time where you have a number of factors relating to our solar system, relating to the Earth's history, that make it ideally suited for human beings to survive. And in fact, it's a relatively narrow window of time. And so that's, we appear at the time in Earth's history when human life is actually possible and human civilization is actually possible. It's a detailed argument that he makes that is found in a book called Improbable Planet that I would refer to you for the details. I'm not a planetary scientist or an Earth scientist, so I don't have mastery of the details. But to me, from a theological standpoint, and again, I'm drawing from Hugh as I make this point, is this, that think about, I have a daughter that's going to be married in June. I've already have had two other daughters married, and the preparations, I really am dreading this wedding because I've been through the planning of 2 weddings. It is miserable. It's absolutely miserable. It's expensive. It's miserable. There's so much work that's involved, so that 2 people that love each other can spend 45 minutes in front of a small group of people exchanging vows, right? And then afterwards celebrating for a couple hours. All that money and time and effort goes into a very, very short period of time, but that time is so significant, and those people are so significant that everybody involved is willing to go through that expense and that effort because of the importance of those 2 people and what that time signifies. So if you think about this, that if everything in the universe's history and in Earth's history is leading up to the advent of humanity, this is what Scripture teaches, and I think in Genesis 1, is that everything that God is doing is ultimately preparing a place so that human beings are possible. and that time, that window of time is even short-lived. Why would a creator go through all that effort for human beings that can only appear at a very late, or appear after a significant period of time in the universe's history and only can survive for a brief window of time? The argument would be those human beings must have incredible value and significance to the creator. So to me, your question is a theological question, and so I think the Christian worldview beautifully explains why a creator would take so long. And when you think about the idea that the entire history of the earth is essentially a process of preparation for the advent of humanity, it communicates, again, an enormous amount of care and love that the creator must have for human beings.
I want to mention that this wonderful facility Temple Hills has given us till about 9 o'clock. So we're very close. They'll probably let us stretch it a little bit. So I'm going to ask that this be the last question, the next one. But before you go, feel free to come up to the book table. Brian, who just walked out, will be up here. There are cards in your seats. If you'd like to be on Reasons to Believe's email list, you can fill those out. That's certainly optional. But we do need to make this the last question so that there's time to give an answer and for time for people to come up here and look around.
Okay, let me make sure that anybody that hasn't had a chance to ask a question would like to ask the last question. If not, I'll... Brad?
I haven't asked a question. Let's grant that proteins were created by an intelligent designer, just for sake of argument, which I personally wouldn't grant, but let's do it for now. How did we get from that thing to a giraffe, if not by evolution? And I posed that question to other Reasons to Believe people here, and I've read a lot about it. And the answer I usually get is giraffes did not evolve from earlier antelopes and other forms, but they were spoken into existence. It's like there were no giraffes on Wednesday, but on Thursday there were giraffes. Now, am I oversimplifying it, or am I misrepresenting Reasons to Believe's position on that? But are y'all championing the cause that most of these different kind of animals are actually spoken into existence in an almost instantaneous manner?
Yeah, I don't know that there's actually a Reasons to Believe position on that question.
That'd be a good thing to take position on.
We actually don't take hard positions on a lot of things that you think we might ought to. And part of the reason is because we want the freedom to explore what the possibilities are and what the options are. My personal sense is, when I look at the history of life, there are key transitions in the history of life. The origin of life, I would say the origin of eukaryotic cells, origin of body plans, the origin of the major vertebrate classes, that to me represent transitions from one regime of complexity to the other, where there's significant biological innovation happening. In my mind, and again, this is not just my opinion, but based on what I read in the scientific literature, every one of those transitions at this juncture is a struggle for evolution to make any sense of, the evolutionary framework to make any sense. And all of these transitions happen explosively without intermediate grades. And Eugene Koonin, who by the way is no friend to our viewpoint, argues that these are biological big bangs, where again you have this explosive innovation happening without intermediate grades. So when we look at, for example, the origin of mammals, there's a mammalian radiation that takes place. About 55, 60 million years ago, right? There's a mammalian radiation. To me, you also see radiations for actually 3 for birds. You see radiations for reptiles, for amphibians, a couple of radiation events, I think, for fish. And to me, that's where I would argue it looks as if a creator is involved. From that point on, I'm perfectly comfortable with evolution happening at the level of a species, a genus, even a family. These categories, by the way, are largely arbitrary too. They're not well-defined biological categories. Species more or less is, and phylum more or less is. So to me, I would say that there are places that I'm not a skeptic of the entire evolutionary paradigm. I think clearly aspects of the paradigm have been well established. To me, I think there are these innovations that happen that correspond to complexity changes or regime changes in complexity that I think right now we don't have explanations for, and they look like creation events to me. Looks like there's an infusion of new information into the system that again, we just don't know how that could happen from an evolutionary framework.
It was aliens.
Thank you all. These questions were stunning. I'm just I almost wanted to stand up and say, look, I'm just the mastodon here. You're allowed to ask a question if you don't have a PhD, but apparently everyone in here has a PhD because all the questions were at this level. Well, dizzying. But
thank you guys for coming, and I'm happy to hang around and chat for a while. I know